Constant propagation. So constant propagation algorithm. This is under artificial intelligence unit 2. So constant propagation. So constant propagation. Uh, that variable assigned a value. Also, the algorithm recomputes that possible value to set and assign the value. So depend upon the variables. The process continues recursively until there are no more changes in the network. So continuous propagation, the how the variable exchanges the variable and evaluate and domain expression of each variable y depend on x. So if the set change, the preference constraint is evaluated selecting one of the possible values as the new assigned value of y. The value that have been assigned by user always preferred long as they are consistent with the constraints. So propagation on confirmation on this start constraint propagation. So the advantage of constraint propagation, the mechanism is that there are no wasted computation. So every constraint evaluation which it could be evolved potentially expensive computation and drawback can be tedious for the user to approve every value and the user interface perspective user and confusing from user interface perspective and propagation with the template immediately fire constraint as soon as possible without crossing template boundaries. This approach offers a good trade-off between computation by the system and input by the user. The system reasons thoroughly within a template assigning value for variable in the template. So, however, the confirmation from user, the proposed template expansion, since a user may choose different expansion. So this is default program stage in at least backtracking search. Backtracking search algorithm, that is the method it is used for solving recursive approach to explain the problem. That hill climbing algorithm, they didn't go they didn't go recursive or again reoccurring that particular node. So sometimes they have the problem, you know, that the local maximum. So if they're having local maximum problem, so they have to backtrack. Then they will be get the solution, or they will solve to achieve goal state. So there is a backtracking used. So backtracking is a symmetric way to trying out different sequence of discussion until we find out the bugs. So backtracking. So this is an example for backtracking the given. So started. So it will be more like that. Then in case the dead end is come again, it come to backside and come to the start state. Then again it will move to some other place. Then it will again come to the starting state. So like that, if it will go up to the dead end, then again it come to the where it will be started. Then it will be moved to so the every time that node getting reoccurring. So a tree is composed of nodes, that tree, one root node, internal nodes, leaf nodes. So like that backtracking can understood for a searching tree particular goal leaf node. So backtracking algorithm determines the solution by systematically searching the solution space for given problem. So the depth first search is a boundary function. Also, yeah, all solution using backtracking is needed to satisfy a complex set of constraints. I'm saying maybe explicit or implicit. So what is explicit constraint and implicit constraint? It's a rule which restrict each vector element to be chosen from the given set. For implicit constraint, the rule which determine which each the you know tuples in the solution space actually satisfy the criterion function. So based on that, so backtracking, I already said for some solution, some might be where that traverse node to the graph. Some places it will be getting stuck because of same value or peak values near with the peak value in plateau region. Like that, sometimes the current state to goal state, the artificial intelligence won't move because of I already said same value like that. So that problem might be so it don't move. So backtracking it is help to move from that place. So when it did come backside, then they can easily to search in another branch. So like that. So backtracking is very important. So next one is game playing. Game playing is optimal decision is games. So game playing means it's a success in which two or more players with conflicting goals and trying to explore same search of the space for the solution are called adversarial search, or else we can say there is a no games. So game playing, two or more players conflicting goals to try explore same search space for the solution. So games are model as a search problem. So hierarchical evolution must function. There is a types of games in artificial intelligence and deterministic and chase moves. So perfect information about deterministic, like chess, checkers, go. So chance moves, backgammon, monopoly. So imperfect information in deterministic, partnership, blind, tic-tac-toe, and bridge, poker, scrabble, nuclear war. So these are the chance to move imperfect information. So what is perfect information, imperfect information, deterministic games and non-deterministic games? So a game with the perfect information is that the agent, artificial intelligence, complete the board. The agent can information about the game, can see each other moves also. Example, chess, checker, go. So these are the perfect information or game playing. Imperfect information, uh, the game not to aware with where what's going on, such type of games like that. So it is a imperfection information game. So example, tic-tac-toe, battleship, blind, bridge, etc. And deterministic games are those games which follow a strict pattern, so set of rules for the games and there is no randomness associated with them. So examples are again chess, checker, go, tic-tac-toe, etc. They're non-deterministic games. So these games varies unpredictable events and has factor to chance or luck. This factor of chance or luck introduced by either dice or cards. So the random each action response is fixed. The games are also called as stochastic games. So example Eka, Monopoly, Poker, etc. So game tree. So this is a game tree, maximum, minimum 0, maximum, max, minimum 0. So like that, so game tree is flow to maximum initial state to up to utility state. So game tree is where that involves initial state, action function, and result function. So example for tic-tac-toe game tree is the following some key points of the game. There are two players, maximum and minimum. Players have alternative time to start with the maximize the result of the game tree, and minimize the result that's a minimum. Okay, thank you.